Welcome to my channel. Today I will discuss another important topic that is relative atomic mass and relative molecular mass or molecular weight and percentage composition. First of all, atom being extremely small, we can see and we can weigh directly. Okay, that's why we can use a term that is a relative atomic mass, which means the atomic mass which relate to a standard atom and a standard another atom. This is the relative term. First of all, before 1961, all the measurement of atomic mass measured, the process was there, that is on the basis of C12, is on the basis of hydrogen atom, which is very negligible weight. That is 1.66 into 10 to the power minus 24 gram. It means it's very negligible weight. On the basis of hydrogen atom or on the base of hydrogen atom, how much time heavier one atom is called was called a relative atomic mass. But later, due to some problem, on 1961, there was a process appeared that is on the basis of C12 atom. If we divide the C12 atom, which is mass is 1.9926 into 10 to the power minus 23. When we divide this mass by 12, we can find 1.66 into 10 to the power minus 24, which is the atomic mass of hydrogen. Okay, so then relative atomic mass. What is relative atomic mass? Relative atomic mass is that one atom, mass of one atom is how much heavier than 1 by 12 of C12 atom. Why it is there 1 by 12? 1 by 12 means I already told that if we divide the mass of hydrogen, that is which is very negligible, mass of hydrogen, if we divide by mass of hydrogen, we can find directly. But if we calculate on the basis of C12 atom, this is 12 atom, this is the mass of C12 atom. But when we divide or when we multiply by 1 by 12, then it will appear 1.66 into 10 to the power minus 24. Okay, clear? That's why we calculate on the basis of 1 by 12 of C12 atom, mass of any element, how much heavier is, or how many times of either hydrogen atom mass or 1 by 12 of carbon atom mass. First, you have to clear that if you use hydrogen atom, you use only the mass of one hydrogen atom, okay, below and above mass of one atom of element. But if you consider carbon atom, then you have to take 1 by 12 of carbon atom mass. That means if we divide or if we multiply 1 by 12 of carbon atom mass, that is 1.9926 into 10 to the power minus 20 divided by 12, that appear 1.66 into 10 to the power minus 24. Okay, that means you have to remember this term, that is 1 by 12 of mass of carbon C12 atom. So it means relative atomic mass or atomic weight is relative term. That's why it is relative atomic mass. That means atom how much heavier. This is the ratio. Okay, how much heavier than the standard atom like hydrogen or carbon. Okay, what is relative molecular mass? Is the same. Here we consider the atom. Now we consider the mass of one molecules of the substance. Mass of one molecule of the substance. That means mass of one molecule of the substance divided by 1 by 12 divided by 1 by 12 of the mass of an atom of C12. That is the same. Okay. Here we consider molecule, but here we also consider the atom. But mass of below that, this is the 1 by 12 mass of one carbon atom. Here also 1 by 12 of mass of an atom of C12. Is clear? Okay. Now, why we use previously we used the scientists use to evaluate the atomic mass or atomic molecular mass, hydrogen atom was used, but why in after 1961 carbon atom? Because there is a property that is the adsorption, adoption least effect, which is called. You can read in a book, in some book it is denoted, but adoption effect is another thing. I will discuss on a session, but at present the time is short, that's why we directly proceed to on concerned topic. Okay. So now if the question is asked that how can you calculate the relative molecular mass? Like this question, the relative molecular mass of copper sulfate crystal. Relative molecular mass of copper sulfate. Here the question is given that relative molecular mass of copper sulfate crystal, that is CuSO4.5H2 and NH4 In this type of question, the question with related to the RMM already given here. You can see the copper is 63.5, S is 32, O is 16. Another thing is that the relative atomic mass, it has no unit like gram or because it is or kilogram, it is ratio. You can use the 1 AMU unit, that is atomic mass unit. Clear? So, or you can simple put the number, calculate the number and put the number as answer. So in this type of question, the atomic mass is given individually. Here ask the RMM, that is relative molecular mass. So you have to calculate like this way. Here the copper is 63.5, and plus sulfur is 32, and oxygen is one oxygen is 16, that means that it is 4, that means we should multiply with 4, plus dot means plus, there are also 5 H2 present, that's why we should put the plus sign, and then 5 in bracket, 1 hydrogen is 2, that means 2 hydrogens present and 16. So it becomes, if we calculate, then it becomes 159.5 plus 159.5 plus 90, so it becomes 249.5. 249.5. You can calculate. The calculation is too much easy. That is 63.5 plus 32, and there is 16 into 4, 64, plus 2 into 1. According to the Botman's rule, you have to calculate the first one is in bracket, that is 2 into 1 plus 16, that is 18, and 18 into 5, that means 19, and put the value, answer should be 249.5. Now in this case, that is NH4 whole to SO4, that means N means 14. N means 14, and 4 hydrogen is there, and total bracket is into multiply 2, that is 2, that is 14 plus 4, that means 18 into 2. So plus 32, okay, and 16 into 4, okay. So this is 14 and h means 1 into 4 plus 32 plus 16 into 4, it will become 36 plus 32 plus 64, that means 132, okay. Clear? Is that clear? It is so simple that 36, this is 14 plus, according to Bachmann, so we have to calculate the bracket calculation. That means 14 plus 4 is 36 plus 32 and 64. 6, 2, 8 and 4, 2, 1 and 13, okay, 132. Clear? Okay. So now the another topic is that is percentage compositions, which is related to the relative atomic mass. This is also the simple part, that is the question, when the question is asked that what is the percentage, suppose question is asked that this is copper sulfate crystal, okay, what is the percentage of copper, what is the total percentage of copper in this molecule, that means how much percent of copper presence, particular element presence in a molecule. This type of question can be asked, okay. And this is also very interesting that in various drug composition, you can see the various percentage of molecule composition means the mixture of various type of molecule or various type of element. So you can find that their percentage is given in various form, okay. That's why this is very important, that is percentage composition, which means that total weight of the element in one molecule, by gram molecular weight of compound into 100. We can take an example like this. Suppose you are given, calculate the percentage of nitrogen in urea. Urea means NH2, CuNH2, this is an organic compound, and also here RMM, that is relative molecular mass or relative atomic mass is given, relative molecular, not relative molecular mass, RM is given, that is N equals to 14, C equals to 12, relative atomic mass is given here, okay. Okay, another thing is that here no unit is there, you can put AMU or you can simply put the number because this is the ratio, clear? Okay. Now, so you have to calculate by like previous process, that is you have to calculate first the relative molecular mass. That means here is given 14, this is 14, okay, N means 14, H means 1 into 2 hydrogen, 12 carbon, and oxygen atomic mass is, atomic weight is 16, and again nitrogen is 14 and 2, this means total is 60, total become 60. Clear? Now what will be the percentage of nitrogen? Here you have to first notice, you already noticed that here nitrogen presence in 2, here 2 nitrogen present, that is there is nitrogen, that means 2 nitrogen is present. Question is asked that total nitrogen percentage, that means you have to put 2 nitrogen weight, here is given total weight of element, already given total weight of element in a molecule, okay. This is the total weight of element of that is nitrogen, okay. By gram molecular weight of compound, that means if you convert molecular weight into gram, then it will become gram molecular weight. That means suppose if you consider the molecular weight of, suppose oxygen is 32, 16 into 2 is 32, okay, if you convert it to gram, then it will become 32 gram. Clear? So now here the total is 60, that means gram molecular weight, if you consider as gram equal 60 gram. Okay. Now total nitrogen is 14 plus 1 28 by 60. Total molecular weight is 60 into 100, and it will become 46.66 or 46.67 percentage. Okay. This is the way to calculate how we calculate, or you can calculate the relative molecular mass and also the percentage composition. Okay. Thank you for watching my video. Please subscribe my channel and press the bell icon to see the new video. Okay. Thank you.